Okay, welcome back. We are in English, right? Most likely. Yes, we are. Welcome back to Lasergurkenland. lgl.sillyhoon.com is the address you want to type in your Minecraft client right now to join this awesome anarchy server. What was I about to do? I can't remember. Let's just build a wall. Yeah, so this is a vanilla anarchy server. This means the server is purely unmodified and it is thus not bound to any bucket or spigot or whatever updates, and it can always be the latest version. It is it includes all the bugs and features from Microsoft, the original server, and it has no rules, so you're allowed on the server to kill other players. You're allowed to say rude words in the chat. You're allowed to raid bases. You're allowed to use hacked clients and so on. So if that is something that interests you and you want to play in a vanilla environment without much players, so it's very chilled here and there are no world resets, and still the server, even though it's not very popular, will not go away. Yikes, since I already paid it in advance for multiple years. Cool. So that's about the advertisement part. Now I'm going to watch a video about Linux kernel development. So if you're into Linux kernel development, go check out the description where I linked the video or the talk that I'm now going to play back in the background. So if you're interested in that, I recommend you watch the original, since that will have the slides and better video quality. Other than that, you should now join the server, and I hope to see you in game. Cool. I need more blocks. And also I should probably remove this whole thing here. I don't know.
Hello everybody.
If I want to
Manuel Schölling.
wait, if I want to drive the machines until here, then I have to remove the mountain and then not sure what to do, I'm not gonna lie. You know what? I said I will do it off camera, but I will now do it on camera. Let me look in how to build a water removing machine if it's complicated. Water removing machine. 2 years ago. Oh, lmao, that's usually so complicated. Let's see. Advertisement after advertisement. So what do we have here? Oh boy, that's so big. I don't want to build something so big. Can it be any more complicated, please? No, I'm not going to do that.
Last year I started I had the idea of participating a bit in the development of the Linux kernel, and I got quite a lot of knowledge how it works, and so I decided I'd give a presentation to share this with everyone. A quick show of hands, who's using Linux? Okay, who has ever compiled their own kernel? Okay.
Oh my gosh, so many hands. Where is this boy?
Contributed to the kernel? What? Okay, great. Good.
What is this audience?
Okay, so in about 25 years ago, actually in the year 1991, Linux kernel, Linus Torvalds wrote this email to a news group announcing his project, and he said it would be just a small project, just a hobby, nothing big and professional. And actually now in the year 2015, it's now probably one of the most important software projects.
Oh, I didn't say the title of the video, what I usually do in the channel. It's a new channel that we are consuming today. This video that I'm currently playing back in the background is uploaded on the free and open source software conference FrOSCon e.V. Is that German? Channel. And yes, it's from 2015 and has currently 12,000 views. And link to the video is, of course, in the description.
And because it actually runs everywhere and on millions of computers. And although he said that back then it's just a hobby, nowadays the contributors look like this. This is the list of the contributors in the 3.14 kernel. And as you can see, the most number one is Intel. You see Red Hat. You see a lot of big companies. You don't see Canonical here somehow. They don't contribute to the kernel, at least back then. But you also see on the second rank, there are developers without affiliation, and the fourth rank are developers which either Greg Hartman couldn't find out who the real developer really is, to which company he belongs, or the company said that they don't want to publish that they contribute to the Linux kernel. But as you can see, the second most, and maybe even if you include the fourth rank, there is still a big amount of hobbyists contributing to the Linux kernel. And although it's quite professional now, we need for development, there are new developers needed, and of course, if they learn before they go to a company how to contribute to the Linux kernel, it's always a plus. So why on earth should you start kernel hacking? Of course, if you have a bug in the kernel and you find this on your computer, you probably want to fix it. And so this could be one motivation. Another simple motivation is just that you want to want to show the world that you can do this, and well, it's a nice thing if you can say that you contributed to the Linux kernel, although even if you just contributed to a few patches. And maybe your motivation is just to play tricks on your colleagues. There is, for example, a Linux kernel module called Kernel, and if you install this on your computer, everybody who opens an MP3 on the computer will get this famous song of Rick Astley. So maybe this is also your motivation. But also, what will happen if you become a contributor to the Linux kernel and write a lot of patches? The industry will notice that, and if you show that you can do a good work, they will get in touch with you. And
okay, so how did it work now? We put one here and one here, facing like this, I think, and then we place a block outside here, and then it should fly, right? And those were like this? No. Oh.
Then this is one way to do this. And on the other hand, if you contribute to the Linux kernel, you help the whole community on the planet who use the software. And also, it's nice to know that your software will run on a lot of big machines in all the data centers around the planet, and will also affect everyone in their everyday life. What actually is required to contribute to the Linux kernel? Well, there are mainly two main skills you would need. One, of course, is knowing Git, knowing this version control system, how to deal with this, how to create commits, how to create patches. This is mandatory, and there is an optional required skill, which is the C programming language. And actually, you don't have to know C to contribute to the kernel. There are also people who just fix spelling errors or fix the documentation and stuff like that. So you don't have to be an advanced C developer to contribute patches to the kernel. But usually when you want to...
Yeah, that's so. If you want to contribute to the kernel to get noticed by companies and flex your knowledge, or do something like almost all the examples he mentioned were involved knowing C, right? And then he's like, oh, you don't need to know C. But yeah, I get the point.
The Linux kernel is always big question is, what do you want to do? So you have to find out what should be your task when you start developing. Because usually, I mean, as I mentioned before, maybe you see that a part of the kernel is really bad documented, and the developer didn't really spend a lot of time showing how a certain module works. So maybe one option is to, when you see that the part is badly documented and you had a hard time to find out how it really works, you can contribute to the documentation and help everyone who also uses the same part of the kernel. Or maybe you have a new gadget and it doesn't really work. Sometimes this is really simple. Sometimes the kernel actually already knows how to deal with a certain device. For example, if you have some USB gadget and the latest generation, there is already the driver, but the driver doesn't know that it also supports this thing. So there are easy patches that you can contribute to the Linux kernel just by telling the Linux kernel, yeah,
fucking
this driver actually also works for the gadget with this USB ID. Or as I said before, maybe you have a kernel crash and you want to find a user.
Oh, that was so useless because I have to remove the machine anyways.
But want to find out what the actual bug is and fix it.
Why does this take so long?
And another opportunity also to get better skills in C programming is just by reading the code, to do code review, and the quality of the Linux kernel is actually pretty good. So you learn new stuff when you read it, but then sometimes you find bugs when you read it, and then you can fix this. But other parts of the Linux kernel are not so well written, and when you read this stuff, you already notice that there are parts that can be refactored or parts that can be merged. So refactoring the code is also a possibility. Let's say you already found your task, and I don't know, you want to create a patch for the kernel, then the big question is how to submit the patch.
Mail.
The general idea is this. First, you clone the kernel source, then you do your commit, you change the code, you create commits, and depending on how complex the stuff is that you're doing, you must repeat the step. You create several commits, sometimes just one commit. In the end, you run two scripts. One is checking your patch, and the other one is determining which maintainers are responsible for the code. Okay, the first step is loading the source. There is Linux Torvalds has a Git repository on GitHub, but this is not the right source for developing the Linux kernel. And sending patches to Linus Torvalds GitHub repository via pull request won't be accepted. And there is the kernel.org domain, and there also Linus has its own repository, but when you develop patches, it should be against the Linux Next repository, which is maintained by Greg Hartman. So this is the very long ID URL, and it's about 1.7 gigabytes that you have.
1.7. Yeah, someone lately told me it's like 200, and I was like, what?
But then you have the whole history of the Linux kernel back to version, I don't know, 0.1 or something like that. So quite a lot of source code and history. And what you will get is a structure like this. These are just the directories in the main directory, and
Root, right?
yeah, you can see that there's stuff like here. Oh, you don't see the server. Okay. Like directories with architecture-dependent stuff. This is probably not so important for when you start developing stuff. Block device drivers are in this directory, cryptographic functions. This is a very nice directory. The documentation, there is a lot of stuff explained, even what you wouldn't expect, how to set up. I think there's also a how-to for setting up your email client to send patches and stuff like that. This is one of the largest directories, the drivers. These are the device drivers, so for all the USB stuff, PCI stuff, and all the things there are...
Wait, find iname to do VCL? Does that mean there are like 64 directories that include the name to do? No way. Or include a file to do?
There are the drivers in this directory. The file system logic is described here, and memory management. This next directory is not for the drivers for network device cards, but it's more the logic. For example, the implementation of TCP is in there. And sound system, stuff like that. And when you search for in this directory for to-do files, you might find in this case 64. Maybe this is a little bit older. This number.
It's actually files, right?
So a lot of developers create to-do files and write down what they want to do and what they actually don't want to do and what other people to do. So if you're looking for a task for kernel programming, you can look into the to-do files, and there are often quite a lot of nice tasks to start with when you develop stuff. And there's this nice coding style file, and just a summary for that, they use tab indentions. The line wrap is about 80 characters. I say about 80 characters because nowadays it's not so, the screens are large enough to show more than 80 characters, and sometimes it doesn't make sense to break just at 80 characters, just to be compliant to the coding style. So you can get up to 90 or whatever, but if you have more characters in one line, there's probably something wrong with your code, and you're trying to express too much in one single line, and you should break it. Should break the line. Another advice is writing clean code. There was a nice talk yesterday by Laura Mitchell, I think, about how to create patches and what you have to remember when you write patches for open source projects. I would recommend to watch this video again. But in general, you should keep in mind that these people don't want any junk in their source code, and these people have to understand what you are doing and why you are doing it, and why they should accept your patch. So you should really try to write good code, and if you do larger commits, split your stuff into several. If you do larger patches, you should split your stuff into individual commits to let the people see how your way of thought was. And you should also, if you provide new code, you should the code should not create compiler warnings, because they are really annoying. And and sometimes the compiler warning really is a warning. It's just a notice, and you should really fix what the compiler warning says. And you should. I think it's a bad idea to just grab the Linux kernel, look for which part of the code generates compiler warnings, and just fix the compiler warnings. Because just fixing the compiler warning is sometimes pretty easy. You just have to cast, I don't know, an integer into integer with 46 bits or something like that. But when you don't know the details of the code, you actually don't know why the compiler warning actually arises. So I would recommend not to say, hey, at first task, I choose fixing compiler warnings, because it can be dangerous. When you create patches, it can be, I would recommend to just create very simple patches in the beginning, just to get to know the workflow, to find out how it works. There was a project called the Kernel Janitors. They still have a website, but I think it's from 2008 and not changed since. And they list some tasks that should be done. And at the beginning, I chose the task to modify a time comparison. So this Jiffies is the time counter in the Linux kernel. And when you have this raw comparisons with the Jiffies variable, you can get arithmetic errors, which was so it was proposed that all these comparisons should be modified to use this function, which is safe against these kind of errors. And the first thing I did was just fixing some occurrences of this stuff. And after a while, some people noticed that I sent a lot of patches. And then they sent an email and sent me a big regular expression and told me, yeah, here you can use this regular expression to pass the whole Linux source code and fix all of this stuff. And so they really notice when you contribute stuff like that. Or this is actually a quite nice example. Also, it's just a very tiny change in the source code, but it makes sense. I mean, for the maintainer, if the maintainer gets this patch, he can immediately see, okay, what should this be? And actually, when you just
no, I didn't pay attention. He was talking about his patches and something about time and.
Choose fixing compiler warnings.
Okay, let's watch this whole part again.
When you create patches, it can be, I would recommend to just create very simple patches in the beginning, just to get to know the workflow, to find out how it works.
Yeah, I would say that's a really kernel independent recommendation that can be applied to all open source. If you are new to a project, just start off with small fixes. and yeah, get used to the feedback workflow and so on. Yeah, that's generally a good idea. Not like developing your own big feature in your basement without anyone, without letting anyone know, and then being disappointed because it was rejected. That is like a bad idea in general.
There was a project called the Kernel Janitors. They still have a website, but I think it's from 2008 and not changed since. And they list some tasks that should be done. And at the beginning, I chose the task to modify.
This one is the wrong one, right?
Jiffies.
So I have to go
the
here.
time counter.
Yeah.
And when you have this.
Fuck! And this one was the wrong one too.
With
No.
Can get arithmetic errors, which.
Okay, now I'm like missing the talk again. If I don't pay attention. So this was really stupid now. What should I do? What should I do? Okay, do I have some stuff left? No. Too bad.
So it was proposed that all these comparisons should be modified to use this function, which is safe against these kind of errors. And the first thing I did was just fixing some occurrences of this stuff. And after a while, some people noticed that I sent a lot of patches, and then they sent an email and sent me a big regular expression and told me, yeah, here you can use this regular expression to pass the whole Linux source code and fix all of this stuff. And so they really notice when you contribute stuff like that. Or this is actually a quite nice example. Also, it's just a very tiny change in the source code, but it makes sense. I mean, for the maintainer, if the maintainer gets this patch, he can immediately see, okay, what should this be? And actually, when you just see this modification, this N to an L, it's not clear why you should include this change. So you should always take care when you create commit messages, which is in this case up here, that you really, in the first line of the commit message, explain what you're doing, and more, not exactly what you're doing, but why you're doing it. So the first line should include the information, why is this change important? Why should the maintainer include your patch to the source? And then you have a free line and a longer text describing this stuff. Sometimes you don't need it. Sometimes it's really important that you include it, because otherwise nobody will get what you're trying to do with your modification. Another thing about commit messages is that you start the commit messages usually with the module that you're modifying. So this is the file that you modified, and you have this directory, and you usually include it there. So when you look at the whole history, the whole git log, you can easily see which part of the Linux kernel was changed by which commit. And the third thing about commit messages is the path of blame, it's called. This signed off by line. So when you are creating a patch, you must always include in your commit a line which is saying signed off by, and then your name and your email address. And because any modification in the kernel, any person who changes a bit in the kernel or touches a bit in the kernel is registered by such a signed off by line. There is also tested by, I think, and stuff like that. So, and if you send this stuff to an email list, and other people have tested it or have checked your code, they will send you an email saying signed off by blah blah blah, somebody else. And you can include it in your commit message to show other people that these other people also agree with your code. And actually, nowadays, especially in software development, there is a lot of stuff like unit testing and stuff like that. This is not so much done in the Linux kernel. It's sometimes even possible that you create a patch and just check it if it compiles, and then send it to the maintainer to include it in the source code. Because sometimes you modify code that you don't have for hardware that you don't have, and so it's not possible for you to test it. But as long as you really are sure that your patch does not create an error, it's fine not really to run the code, just to patch, just to compile the code. This, of course...
Such English skills on the 1k by 1k square. This is like the worst sentence ever. I don't know how to express myself. How to call this area? I don't know.
This is not true for big changes. For big changes, it's really hard to assume that the code is fine without really running it. But for one-liners, for the one-line modifications, this is not a problem. Once you've created your patch, you can run the check patch script against it. And the check patch script...
No, I'm too lazy to give some tools.
A while ago, yeah, this is one of our first patches is modification with the comparison of digits. And yeah, I don't know, I was used to my own coding style, so so the script, one of the things that the script does is checking the coding style, and as you can see here, there's a space missing. Meanwhile, I already changed my personal coding style to match with the kernel coding style, so it tells you these simple syntax or coding style errors, but it also checks more complex stuff like deprecated functions. If they're used, it gives a warning and tells you, this is deprecated, you should use another function. And what also sometimes happens is that you forgot to include the signed off line in your commit message, and it also checks stuff like that. And let's assume you have created your patch, and you've maybe even tested it for your hardware if you have this hardware, and you ran the check patch script and everything is fine. Then, especially in the very beginning, I would say, okay, go away from the computer, go outside, have coffee, go for a walk or whatever, and then come back and have a look at your code again and check if it's really good, if you can even refactor it to make it a little bit better, to make it easier for the maintainer to see how this patch works. And if everything is fine with your patch, you can run the get maintainer script against your patch. And what this will do, it will check all the files that are touched by your patch, and find out who is the maintainer of this file, and will print this list. For the ISDN stuff stack here, there's quite a low number of maintainers, So it's just these constant here, and if you touch the I don't know, the network stack, for example, you will get quite a long list. What I do then is I just include the main 5 most important people and send them the email. But you should always include the mailing list, which is here, the mailing list for the network devices, and the complete Linux kernel mailing list. So this last mailing list is really huge. There are hundreds of patches going there every day, and I wouldn't recommend to subscribe to this list. Just look at the archives. But you send out this patch then to the maintainers, and there is actually a special function for that. So you don't do the pull request or something like that. That's not how it works for the Linux kernel. You can configure, and I think you should configure Git to do this for you, because from what I heard, there are a lot of problems with email programs. They introduced line breaks somewhere, or scramble with the patch, and so people won't get the right patch, the correct patch. So setting up the Git for that, there are patches on this, how-tos for this online. This is easy. You just have to tell the SMTP server and the password and the username, and you send the patch. And then you wait a bit, and depending on how many people are interested in this part of the Linux kernel, you will get emails either quite quickly or not so quickly. And yeah, if you start with one-liners, it's really it's quite likely that your patch will be accepted. And if you do bigger modifications, it's quite likely that they come back to you and say, okay, I don't like this part. Why do you do this? Maybe some people even say, okay, that's correct what you're doing. But if you start with very simple patches, it's quite likely that they are accepted immediately. There is. It doesn't only help you when you, even if you don't want to become a Linux kernel contributor. It does really help you if you do it just once or twice for fun, because you learn how the kernel development works. And a while ago at work, I had this big kernel crash frequently, and I decided, okay, I must find out how to fix it. And it was in some caching function of the Linux kernel. And when you learn to create patches for the Linux kernel, you learn what information that you should provide to the maintainers to help them to fix stuff. And so I got in touch with the maintainer. So I used this get maintainer script to find out who is responsible for this file. And he was David Howell at Red Hat, and he was really helpful. So we fixed this stuff within 1 week, and as you probably know, there are only two hard things in computer science. One is cache invalidation, the other one is naming things, and here it was cache invalidation, and something else. This was one of my patches, so I reviewed some code in the DNS resolver. So I just read the code, and I saw something is off there, and I found out that there's a off by one error right here, and so I created a patch. I don't know, it wasn't really my best day, because actually the patch that I created, there's a bug included there. Can anybody spot the bug? So I fixed the off by one error here, and I reintroduced it right here. So this was a little bit embarrassing, to be honest.
It was like this, right?
And
Yeah.
I sent this mail, this patch to to some mailing lists, and within a few minutes, I got an email saying off by one error. So they spotted it immediately. So of course, this is embarrassing, and I've heard from a lot of people that they are actually afraid to contribute to the Linux kernel because in the press there is a lot of bad news, and sometimes there are people who are not so nice
What?
and shout at you.
Why do I suck so hard?
There's also community within the Linux kernel community who don't want so harsh discussions. What I always think when I get an email like that, some people trolls get away from the keyboard, come back half an hour later and try to see what is the real criticism, what is actually wrong with your patch, and how can I fix it, and yeah, you shouldn't really shout back because this is leading nowhere. Yeah, there is first of all there's this great source of information in the documentation folder, but there is also the Kernel Newbies website. They have great information about developing the Linux kernel, and they have this IRC channel, and they are really nice people. There are, I don't know, hundreds of people, and nobody's talking. And when you go there, you can ask questions, and they're very helpful. And yeah, when you have questions about code, you can ask there, and sometimes also
I don't know if that was faster because I blew up the wall, but
yeah, if it's not directly about
it was
code, if you ask.
like removing the pistons takes so long. I should probably find a workflow to remove them faster. Yeah, I don't know. We will see.
Hey, I want to modify this part. There is a dependency on another part of the Linux kernel.
Maybe I should build this part out of
should I
Obsidian,
start doing this?
and then I can use TNT. That's maybe an idea.
They were really nice and helpful there. And there is, maybe some of you know this, there's this Linux Insight Git book. This is quite a nice source. For example, there's a description of what are the first steps that the Linux kernel does to initialize hardware, and how does it do, I don't know, memory management and stuff like that. So this is a nice source to find out how stuff works in the Linux kernel. And yeah, I think that's already it. Any questions? Yes. Anonymous. I'm not sure. I don't think so, because they always have the path of blames. You agree? Yeah. So. Yeah. I have to repeat it for the video again. So there's no way to submit real patches anonymously, but I mean you can create a fake identity, or create a fake email address and send stuff like that. But I don't know if it's really. So sometimes in respect to the statistics there are unknowns because you couldn't really find out from the email address where if this person is a professional contributor or not. But in general, no, it's not possible to do this. And why would you do? Answer. Okay. Yeah. Well, I usually just create new branches, yeah, and there I create a new patch, and yes, then I send the stuff out, and I try to manage the communication about the patches in my email program in different subfolders to keep track what patches are accepted and which one are not, and usually I do this. But yeah, from the code side, just create new branches, and because I mean this kernel is also quite big, so if you copy the whole Git repository, yeah, you will get a lot of this space wasted. The question was, how do you do it with big refactor?
So what side is it now on? Is it this side or is it this side? I think if it's okay, let's use the brain real quick. I hate using my brain. So if this one is triggered first, it triggers this one, and then it's pushing, right? So we want to push in this direction. This does not make any sense. I don't know. So maybe if we activate this one, yeah, whatever, and then this one, and then this one.
Not to get into conflict with other people. This is actually quite a problem, yes. So you have to try to create good code, and so that the maintainer really can understand your code quite quickly, and to help that your stuff is included quickly in the kernel before somebody else changes it. But I think there are also other repositories for, I think, for example, the network guys have their own repository, and so their changes don't interfere with other stuff, and depending on the path that you change, there might be a different repository that you should. No, I mean you can send it. I mean in this mailing list there are hundreds of emails anyway. So if you announce this won't probably won't bother anyone. Yeah, I mean if you, I don't know how big your changes should. I mean you should also try to include just small changes, and if you create big modifications, it's less likely that they are accepted because they destroy everything. I remember the story that once some guy, years ago, some guy changed a big part of the network stack, and then a week after his email address, there was a problem with the stuff, and his email address was deactivated, so the account was deactivated, and the person was gone, and they had to deal with this. So the smaller your patch is, the more likely it is that it's accepted. I also gave this presentation somewhere else, and there somebody came to me after the talk and told me that he created a whole bus, implementation of a bus, of a new bus that Linux right now does not support. And he told me that he was just afraid to send it to the Linux kernel mailing list, because he heard that from the press that there is always such a harsh discussion, and I think this is really not necessary, and you shouldn't really have a big, there shouldn't be a big barrier to contribute to the Linux kernel, and I think Kernel Newbies is a nice source for help with that. There is a unit testing framework, I think, right now in the part, I don't know in which directory, but actually, to be honest, I don't use it. Nobody uses it, I just heard. What I heard here quite often is that if it boots, it works. So that's usually the test. And nice. Usually for device drivers, this is probably right. But yeah, which IDE do I use? Depends on, yeah, maybe Emacs for bigger stuff, maybe just Nano, or I think the IDE is not really so important for developing the code. And because, I don't know, when I need a little bit of documentation, I look in the documentation folder, or in fact some cross-references in the C code. There is a nice website, which I cannot remember right now, where you can look up where is a certain function declared and jump to it. Ah, yeah, lxr dot free electron. Okay.
Okay, so which side was it, right? I used the brain last time. So it's the side pushing first, which in this case is this one. Yeah, I'm slowly understanding it. Or like remembering it. More like remembering than understanding. Yeah. At least I do. So, no.
I mean, of course you can configure big patches. I wouldn't do this in the very beginning. It's very
is it stuck on the...
But, of course,
oh yeah, it's stuck down here.
If you have a great patch and it really makes sense to include it and fix the stuff or it refactors stuff in a good way, then it will be accepted. That's not the problem. But the more you touch, the more you can break, and there you have to take care. Yeah. Yeah, just always do one thing in one commit and one thing in one patch, and don't mesh stuff together. Right? Yes. I mean, the Linux kernel is released every roughly 6 weeks or something like that. And actually, I think it's quite fast. To be honest, I don't really. I can't tell you a timeline, but I think within a few weeks or months it will be in the mainline kernel. Do you have any particular?
I think it would be a nice idea to only build the machines on one side, since you can stay on that side while loading the machines without moving, and on this side there can be some automatic destruction method by a T-duping thing that flies up here and Obsidian protecting the wall. I think that would be a cool thing. There are these pretty simple static TNT dupers that you can activate with a lever if you put a how are those things called? Those circling, repeating stuffies. You know what I mean. If you attach those, you can have a constant spamming TNT duping thing up there. I think that will be quite helpful for like the last 6 stages left, to remove the annoying part of destroying pistons. But I have to look up how this machine is built again. That's something for the next episode, I would say. I just have to remember.
So it shouldn't take really long, maybe a few weeks, maybe a very few months, but it should be fast. I can also recommend, there are on YouTube there are a lot of videos of Greg Hartman, where he explains exactly how it works, and even writes a patch during the presentation and sends it out, and there you can nicely see how it really works. I would really recommend it if you
that's cool.
to watch this video. Okay, thank you very much.
Alrighty, so that's the end of this presentation, which means that's the end of this advertisement stream. Make sure to check out Lasergurkenland, the Vanilla Anarchy server. And I hope